Evening, everyone. We are very excited to present to you today our capstone project, Road to Zero Poverty, a machine learning approach to alleviating poverty in Cabanatuan. So in 2021, the PSA reported over 26 million Filipinos living below the poverty threshold. That is living on a salary of 12,000 pesos a month in a family of five. And this is actually much worse compared to the 2018 census data. And the reason why poverty remains to be such a big problem today is because it is multidimensional. While one may have a source of income, other problems like access to safe water, education, crime and safety, among many others, further complicate this issue. So in collaboration with the local government of Cabanatuan, we aspiring data scientists will be investigating poverty using their CBMS or the Community-Based Monitoring System of 2018. In a nutshell, the CBMS captures the impact of macroeconomic policies on vulnerable groups. So to do this, you gather data at the household or individual level, gather their demographics with an attention to vulnerable groups. And then from this, you can get global progress indicators like the UN's SDGs for 2030. So this leads us to our research question. That is, what data-driven solutions can we provide Cabanatuan in alleviating poverty? To achieve this, we have three supporting objectives. First, we want to uncover the factors affecting poverty at the household level. This will help us identify the pressing issues at the micro perspective. Second, we wish to quantify the factors of poverty with most impact at the barangay level. Because solutions are more large scale in nature, it is best to weigh its risks and benefits. After finding the what's and by how much, we also want to strategically allocate these solutions throughout the city.
Our dataset, the CBMS 2018 Cabanatuan data, initially has 72,000 households. In the features, CBMS has 14 core indicators that are measured in the domains shown on screen. For this study, the labeling whether a household is poor or not was already available in the dataset and is based on income threshold. These are the 14 CBMS poverty indicators visualized, with red representing poor households and blue for not poor households. Five of which were experienced mostly by poor people, while far more indicators are also close to the majority. This map shows the prevalence of poverty in barangay level. The darker the shade is, the poorer the barangay. Despite being a first-class component city of the Baisia, Cabanatuan has a high poverty rate of 27%, equivalent to 18,000 poor households. Comparing to the national data of the same year, the city is 10 marks higher than the 17% national baseline. This is a long road towards the SDG no poverty metric of 3% by 2030. Looking in the age demographics, 66% are in the labor force. These residents are ages 15 to 64. Based on class composition, the poverty is most prevalent in the young age group, with 41% of them living in a poor household. This implies that poor residents tend to have more children. Having said that, let's look in the health of the infants. 49% of the reported infant deaths belong to the poor households. But looking in the breakdown of the barangay level, there's a wide distribution. Some barangays have all deaths belonging to poor households, while other barangays have all deaths belonging to not poor households. Another indicator to look into for children is access to education. For every 100 poor Cabanatueño children, 90 enrolls to elementary and 10 does not even enter school. 68 enrolls to high school, and 51 enrolls college, which means 49 have no college access. Lastly, we're curious if the work opportunity in the city is sufficient. Cabanatuan labor force has a smaller unemployment rate of 4% versus the national baseline of 5%. Of these unemployed residents, only 30% among them is poor. These are just some of the variables covered by the survey. Looking into each of them independently will not point us on which particular ones dictate poverty. Whilst there are indicators with majority poor or majority non-poor, it does not completely characterize the poverty situation in Cabanatuan. The data per se will not answer our questions like, how do we strategically alleviate poverty in barangay level? Thus, we came up with three parallel models.
Each of these three models specifically addressed a study objective. The dataset was first analyzed at the household level. After resampling and scaling, gradient boosting classifier was differentiating whether a household is poor or not. The other approach is investigating at the barangay level. Multilinear regression was utilized to quantify the impact of features, while K-means clustering produced barangay clusters grouped based on their poverty-related characteristics. Here's how our models performed. The gradient boosting classifier was used to understand what features greatly affect the household level poverty. The classification model optimizes the recall with a hypertuned output of 73%. Our group is interested in recall score because we want to lessen the false negatives. For example, incorrectly classifying a poor household as non-poor. Secondly, the multilinear regression, on the other hand, calculated the impact of features in the barangay level poverty. The model performed well as evident by 0.61 R squared versus the generally accepted 0.5 R squared in social science studies. Lastly, K-means clustering answered the question, how do we allocate the limited resources of Cabanatuan City LGU to ensure effective poverty alleviation? The highest silhouette score of 0.43 was used to validate the most optimal number of clusters, which is 4. For better understanding, let us walk you through on the 3 models. To answer our research question, which factors have the most impact on poverty on household level, we use classification model. Let's take a look first in the dataset. It can be noticed that the dataset is imbalanced because there are more non-poor households than the poor ones. To address this imbalance, we use resampling techniques to match the number of data for poor and non-poor households. Specifically, we used undersampling and oversampling techniques to balance the data, each with 6 different classification models. Gradient boosting classifier with SMOTE had the best recall validation set scores without overfitting the training set. We then improved the model by hypertuning it to get the best parameters that would result in the best recall score and with high accuracy. It resulted to an improvement of 61% for recall score and 9% for model accuracy. The graph shows the explainability of our model. It is worth mentioning that the model captures the complexity of poverty in different dimensions. It can be seen that having many working members can mitigate poverty, but income may be overwhelmed through number of dependents, their educational needs, and current living conditions. To illustrate this, parents with many dependents have no time to do other things. Or, non-poor households have few children, therefore, they can focus their energy on other things. Finally, we can encapsulate the factors that have the most impact on poverty at the household level through the following. Too many mouths to feed. It means poverty is characterized by large financial demands on a small income household. This is also supported by the most important features of the classification model, which are dependents aged 0 to 14, number of members working, and eligible working members. Given that poverty is multifaceted, you can give 2 recommendations. For short term, we suggest having targeted cash program for household dependents, and in the long term, invest in areas such as education, technical skills, to break the cycle of poverty.
To reiterate our model overview, the linear regression shows the approximate linear relationship of variables to the proportion of poverty at barangay level. To give context on how we shifted our attention from household level to barangay level, we transformed our given dataset by grouping all columns per barangay and get their proportion. For example, we get the proportion of child death by summing all the child death in a barangay divided by the population of children in that particular barangay. Exploring other metrics in evaluating the regression model, let's look at the middle plot, which is the residual versus fitted response plot. This shows that the model overestimates its fitted response if the prediction exceeded 50%, while the plot on the right shows the residual or errors follows normal probability plot, which is acceptable in linear regression. Here are the relationship of chosen feature with p-value less than 0.05. Percentage of poor per barangay increases with increasing proportion of child death, experience food shortage, no access to safe water, unemployment, illiteracy, and age dependency. Interestingly, percentage of poor decreases with increasing proportion of victims of crime and not going to college. The biggest factor increasing the poverty is the proportion of child death. In a barangay, holding all the variables constant with 1% increase in child death, there will be 2.4 increase in poverty in a barangay.
To answer the question, how can we strategically allocate our solutions in Cabanatuan, we use K-means clustering. This enables us to prepare recommendations tailor-fit for each cluster of barangays, of which we identified 4 in total. We then map these clusters so we can see where each is located and how they are spread out across Cabanatuan. The first one, the security and basic education cluster, is quite distinct from the others. With only one barangay, this cluster's main problem is not poverty, but rather the occurrence of crime. Since there are a lot of businesses, it is not surprising that this will be the case. In addition to that, illiteracy among children aged 10 and above is also evident, but keep in mind the population is only 100. That being said, we suggest to invest more on security and law enforcement on this cluster. With regards to the illiteracy problem, it could also help to implement programs targeted towards children aged 10 and above, focused on activities such as reading and writing. The second one, the higher education and livelihood cluster, shows high number of those not in college, unemployed, and the number of dependents. This could indicate that there are a lot of large households where the older children cannot afford to go to college, but at the same time, they are hesitant to go to work. With this information, we suggest to provide livelihood trainings and alternative education programs for college-aged individuals. The third one, the technical opportunity and childcare cluster, has a high number of those not attending college. This could also mean that there are a lot of college-aged individuals who cannot afford to study, but at the same time cannot decide if they will apply for work. Although quite poor, these barangays have a lot of people capable of work. In addition to that, it has a relatively high number of child deaths compared to the preceding clusters. This could indicate a need for a community-based early childhood healthcare and development program focused on children aged 5 and below. For college-aged individuals, provide trainings like technical vocational programs to utilize this section of the population. The last one, the sanitation and food shortage cluster, has the most number of poor households and dependents. Compared to the other barangays, they also have the highest number of households who experience food shortage and has no access to safe drinking water. There are existing programs such as the 4Ps designed to address this problem, and it seems like this cluster could benefit the most. In addition to that, investing on projects that will make safe drinking water more accessible could be very beneficial. While these clusters put the barangays into different categories, it's worth noting that they're still quite similar and could share the same problems as the others. That being said, a solution recommended for one cluster is not exclusive for that cluster alone.
So now we return to our problem statement. What data-driven solutions can we provide in alleviating poverty? So in addressing poverty at the household level, we have our classification model. To quantify factors with the most impact on poverty, we have our linear regression. And for allocating these solutions, we have our clusters. The results from all of our models are neatly summarized in this roadmap, which we'll be providing to the LGU. So for example, in the case of health and nutrition, we encourage in the short term providing goods and health screenings for newborn infants, and in the long term to build awareness through seminars on pre-pregnancy and prenatal care. These are then applied to the clusters on the right. Lastly, we want to make it clear that these are not absolute solutions in alleviating poverty, and its use case is limited to Cabanatuan. We recommend future studies, however, to explore other features not explored by the CBMS, such as teenage pregnancy, source of living, domestic violence, and many others. But we recommend that our methods be used as a blueprint in analyzing other LGUs. We encourage non-specialists to explore our models through the Streamlit link below. And lastly, we hope to empower LGUs and all individuals to incorporate machine learning in reaching zero poverty. Special thanks to our domain experts in community development and social work for the guidance and completion of this project. And that concludes our capstone. Thank you, and we're ready to take your questions.